Code used in the circuit has a low pass filter inbuilt, most accurate data with the least amount of errors, as you can see on the MATLAB simulation shown in front of you. There was two versions of this circuit made. One that was physically made and tested out using a real Arduino and physically tested without a low pass filter, but used a low pass filter in the code. And a second design where it had a low pass filter inbuilt into the design. So we first now have Proteus open up, and you can see the lights are flashing. If we mess around with one of the potentiometers, we are able to see how the light changes when the button is pressed. So at mid-range, it goes at a slow, intimate speed. At a higher range, it goes much quicker with the light flashing. And at a much lower resistance, it goes much slower. So this is the code that will be running. This is with the filter, and this is with the code. And to test out the circuit, so here's the circuit. It uses 3 LEDs as with a push button and 2 potentiometers. So first of all, when the button is pressed, you can see how fast the lights turn on and off. It goes in a sequence that way. When this changes to a different speed, so much lower, you can notice the button pressing and how it affects the lights. But then this potentiometer affects the brightness. As you can see now, you can barely see it. And when it rises, it's much brighter. We can also plot this on the Arduino Mega, on the Arduino software. So as you can see here in green, this is the light intensity, as well as this is the speed. So from this can help visualize it in a better place. And to then show if the button is working, you just have to press, if you do see below, it will move quite a lot. But this is the whole circuit. And then here, so this is how it's attached up. So each cable is connected to each pin using Arduino Mega. And then to test out if it was working, a oscilloscope was used, my own one here, which a 10x probes were used to gain data.